So this talk involves a demo that takes 25 minutes to complete, mostly in the background. So we're going to start off with part of the demo, and then it all makes sense as we go. I've struggled so you don't have to. I've built probably 20 Kubernetes clusters today alone in preparation for this talk, and about 40 for the last time I did this talk, just to make sure everything should go as planned. So let's quickly go over here. What I've got on my file system, well, is a bunch of demo ones. We're going to make a fresh project, fresh GitHub repository, fresh CI pipeline, fresh cloud, you name it, we're doing that. So we're going to create a repo in the 6-up repository, and we're going to call this one Django 10 for the 20th iteration of Kubernetes clusters. And we'll make sure it's public. You all can check this out if you go to that repo as we push. Actually, you'll be able to watch the GitHub actions go as we along the way too. Next bit is we're actually going to build this project out. So we're starting again with nothing on the file system. We're going to template up from a scaffolding, a DjangoCon project that is a 6-up, full stack opinionated. This is how we think things should go on a Django project. And I'll talk about that as well. So DjangoCon 10. Oh, shoot. Grr. Of course I mess it up. One typo. Again, I've run this like 10 times this morning. You'd think I'd have it down by now. 10, 10, 2, 2. Here we go. So, and it's actually going to have DNS hooked to it too. So if I put in here DjangoCon 10.scaf, at some point at the end of this demo, you'll be able to go to a URL that has been published through Route 53, all orchestrated, no click salad involved at all, into a specific AWS account, which I can find right there. And I do want a Next.js front end. We're going to use K8s, so K3s for our Kubernetes, single node Kubernetes. And then we're going to push this into actual GitHub as we go. So into the 6-up org. What this is doing behind the scenes is laid down a bunch of files on the file system for a Django project that has a Postgres backend. It's actually running a Kubernetes cluster locally. So during this talk, 2 Kubernetes clusters will be harmed. The one's running in kind on my local machine. It's going to have the Django part and the Next.js front end, plus the Redis and the Postgres pieces in there. And it's going to be all with our developer experience piece. So if you've actually followed my talk from like a year and a half ago or 2 years ago, I did a couple talks on SCAF from a developer experience standpoint. This is like the next step of that, which is, great, I've developed stuff. What happens next? So this is the GitOps. I'm going to deploy to Sandbox. I want to deploy to production. I want to have an actual product running with a URL that people can get to. And they've solved all those things. Actually, who in the room loves doing deployment? Like that's their favorite thing. Oh, we do have a couple. Okay, sweet. You're my people. Because I love deployment and I love this stuff. But it can get tricky, obviously, if have you been able to deploy from scratch a Kubernetes cluster in 25 minutes while on stage? Okay, good. Then you're again my people. So we're in the right spot. We're going to quickly go over here. If you want to check out these slides, ignore the PyOhio bit. I did give this talk at PyOhio. I didn't have time to make a fresh repo for the talk because they let me know I was going to talk up here like Friday. But that QR code goes to the GitHub. If you just go to 6-up's GitHub, you can see the talk in there. The slides are in there. All the content's in there. There's a PDF in there. Actually, you can click on a link and see these slides almost in real time with it as well. And let me double check that things are moving along on the demo because I can't wait too long. It's getting real close. Okay. Why even talk about GitOps? Like we've talked about deployment. I mean, back in the old days, we used to like SSH into our server. Maybe we telnetted into our server and had Apache we compiled from source and with a web root, and we threw stuff in that folder, and man, we had a site up and running, and it was live, and it took no time at all. Well, that world has changed, and now we have these complex apps that are actually applications. They're not just websites. We're building full-blown apps that are doing, work of value for folks. Okay, here, this is getting ready to go again. Yes. Right now, it's actually pinning all of our Python packages. So by default, SCAF starts fairly unpinned. And as you build new projects, we pin them as you're doing like a greenfield new project, so you don't start off with like a bit rotted state of like your Django and Postgres instances and Redis instances and things like that. So I'm going to wait for this to end because I want to make sure I can keep this moving forward. DjangoCon 10. And you'll see here I'm using Nix to make sure my environments are sane, and I'll talk about that too. Oh, come on, go. I ran this file again 10 times this morning to make sure I wouldn't run into this part of the problem. But I think it's looking pretty good. All right, there we go. Nice. So we're going to check this code in. We're going to push it into GitHub, which is going to trigger our first GitHub action, which is going to build some images, which is pretty awesome. Git, checking this. Init, git, push. And we're going to do something, we're going to branch here so we can go working off of our develop branch. So we can start establishing a GitOps workflow where work can be done on develop branch, that can be pushed into sandbox, and when work is done on pushed or merged down to the main branch, that can automatically go into production, for example. Oh, it's waiting for me to, it's asking me questions over here. I was looking over there. My bad. Git, check out, develop, and we will push develop up too. Not develop, develop. Okay, now we're like fully ready to actually run the magic command, which is, wouldn't it be great if I could just type deploy sandbox? And that got me a day 0 working Django app in the cloud as a sandbox ready to test. That's what's going to happen here right now once I actually do this. Sometimes it doesn't like the this login state of the Amazon SSO stuff. So this will actually ask me, it's going to pop open a browser window. You probably can't see it. Oops. Going to accept and continue. So it popped up an OAuth login or window over here, and now we're back at it over here. It's actually going to also use security groups right out of the box to ensure that only my laptop, which is on a VPN back to a static IP at my house, so none of you can mess with me, that it's only going to have that access for the Kubernetes control plane and any other like the Argo CD bits are all protected, and any SSH is also protected. Okay, now that that's rolling, I'll get into the rest of the talk. Okay. So with GitOps, we get a bunch of big benefit here is that these applications are complicated to deploy. They can be fraught with human-prone errors. Anytime human's in there clicking in the console or even doing CLI-type commands, there's always a chance for someone to go in and kind of fat finger something. And we try to avoid that. We want to make this as automated and push-button as possible. And the big benefit here, too, is GitOps gives us this single source of truth. There is it contains all of our deployment artifacts, all of our code, all of how we want something to happen. And then it's declarative. It's not going to be how we build something. It is what we want built. So we're using Terraform as one of our opinions. We're using Kubernetes manifests as another set of our opinions that describe the end result of our environment. And then the tools go make that happen under the covers for us. That automatic reconciliation gives us the ability to be doing this continuously. So as people may go in and try and make configuration changes, we'll actually be able to protect against that level of drift because the system's watching for those changes actively and actually going and fixing and putting things back in if someone did something they weren't supposed to. We've got the whole poll-based deployments. You can also do like webhook deployments in that there's no more kubectl apply from your laptop. Like thus, you don't want people touching your production environment. You didn't want people touching your production environment when you had shell access to it. You definitely don't want them touching your production environment when they've got a kube configuration file sitting on their file system that could talk to production. So we can actually eliminate that whole level of security issue by now protecting who has access to that Kubernetes configuration file. And as a bonus, we get a beautiful documentation of our infrastructure that runs this application. So under the covers now, we know what's going to be built out and can be rebuilt out in a moment's notice, well, hopefully, as we're doing here, Let's check in on our process. Yep, so it's actually up there getting all the providers for Terraform currently. And so we get all the documentation that goes along with that and all the testing suite that can go along with that. We can actually now test our build, test our integrations, test our infrastructure pieces. So that sounds great. Like, I would love that for any application. But if we want to specifically talk about why we want to even have GitOps for Django, but Django itself is an application. And so we want to be able to roll back an application. So with GitOps, we get the option of, I can push changes and preferably roll forward and build new images and deploy those images. But if something goes awry, I can now go into my GitOps platform where in this case, we're deploying Argo CD as part of our GitOps platform. And we'll be able to go in there and actually, with one click, redeploy a previous version of an image. We want to build, again, environment drift protection. I kind of mentioned that. The development environment, the staging environment, the sandbox environment, the production environment can now all stay in sync with one another, and they move forward together. So as I make changes in my local environment, I can now programmatically roll those out into other environments with a process. It's all been codified. Another nice bit here is we're using a CI/CD model for this, which means we can use security tools like OIDC Connect on GitHub Actions to talk to our Amazon infrastructure. And no one has to store a AWS. How many people love storing and handling AWS secret keys and whatever the other one is called? I don't even want to deal with them anymore. I want to SSO in myself, and I want the tooling to actually use a similar type of an infrastructure to identify what role it has when it's going and interacting with my infrastructure. And so I can do that now with the CI/CD pipelines and control this whole thing front to back. And that gives us, obviously, a nice foothold into some compliance pieces. You get a complete audit trail of who's done what, when, and where, and how. And like I mentioned before, you also control who has access to that kube configuration file, which is with that, you can't do anything on a production environment, for example. And each environment, so in this case, you'll see we're using sealed secrets for our key storage. Those sealed secrets are tied to specific environments. So the sealed secrets for Sandbox only work on Sandbox. The sealed secrets for production only work on production, and only if you've got the kubectl for production. So you've protected that from, you've given people kind of a least privileged stance on how they should approach this infrastructure. All right, a little between slide, check in. Ooh, it's going a little slow. We'll see how this Wi-Fi does today. Everybody hold your breath and stop using the Wi-Fi. Okay, so then now I've kind of avoided the elephant in the room. Like, I know there are folks out here who are not using Kubernetes yet. Who in the room is not using Kubernetes? Yeah, I knew it. I knew you were out there. And I think there's been reasonable arguments for why that is. It is seen as very complex, maybe overkill, maybe just too much overhead for a small little application. But I'm here to tell you that has changed. I feel like the tooling has come along and actually provides us with a great platform for using this from front to back. Everything, actually, who runs Kubernetes in production but doesn't use it locally? Raise your hand. Yeah, so the same people who said they're using Kubernetes are not necessarily using it on their laptop. I'm using it locally, and I would entertain that everyone here, or try and convince everyone here that is actually a great way to develop, because now I can catch issues on my local machine before they ever get into production, before they ever get to Sandbox. I can iterate as fast as I'm running the code locally on my own machine, but I'm using in the container environment. I've got all my developer tools. I've got all my nice environment wrapped around me, and I get to do it because I can use a tool like Kubernetes. I know a lot of people think Kubernetes is this fancy orchestration tool, which it is, but I feel like Kubernetes' real benefit is the control plane, that API programmatic access into being able to control how and when and where and what happens with your deployment of your application. I'll talk about a little more of that later too. But I kind of made what I thought it would be convincing arguments that you should be running your Django applications under Kubernetes. And the biggest one on my list here is probably actually the bottom one, the cloud agnostic. No vendor lock-in. If you've got your stuff deployed in an EC2 instance, well, you're on an EC2 instance. You can't pick up that EC2 instance and move it over into GCP. It doesn't work that way. You would have to now redeploy your application and figure out all the manual bits you did along the way to make that happen, where with the tooling we're talking about here in Kubernetes, you can be using GKE, which is like the managed Kubernetes from from Google. You can be using EKS, which is Amazon's managed Kubernetes. I'm not using either of those. I'm using a cloud agnostic open source Kubernetes distribution to deploy this. And for production, we typically use something like Talos Linux, which has no shell access to the actual virtual machines whatsoever, and the file system is completely immutable. So negating a whole class of security risks and issues that are possible. So we get, again, I feel like it's the resource efficiency. If you do get more load, there's tools like Carpenter, for example, on Amazon, and actually I think it works in other environments too, that can scale up your number of nodes behind the scenes for you based on whatever metrics or algorithms you've defined for your application. You know your application best. You're going to know when it needs to scale up, and now it can do it without you intervening, or at least at a controlled fashion that gives you that flexibility. The zero downtime deployments just come out of the box. Like you now can roll out new features, new code, and it will deploy those containers onto the cluster for you, and then wait for all the traffic to go off the other ones, make the new ones live, and there's like basically zero downtime as you go and deploy and deliver these things. And then the kind of list goes on. Like there's just a lot of benefit, I feel like. Oh, this is not good. This is not going fast enough at all. We'll see what happens. We may get a deployment. We'll see what happens. And then secrets management. I think that's another important one because we want nothing left unencrypted as far as a secret goes. When I'm actually deploying up here, you saw it pushed into GitHub. It actually I use 1Password. I'm a big believer in 1Password. I love 1Password. They've got a great command line tool. They've got great integrations with the Mac and the other tooling around it. It actually asked me for my fingerprint to use SSH keys to push my code up into GitHub. There's no private key on my machine at all, other than an encrypted one in the 1Password vault. Same goes for any of my other secrets that I'm doing if I did need any kind of API secrets for Amazon. But that allows me then to build the sealed secrets, which is going to be a file generated locally, but using the sealed secrets operator in the cluster to build it so it's attached to that cluster. And then I check that in, and it's fully encrypted. There's no plain text passwords passed around anywhere. The cluster knows how to unencrypt it, and that's it. That's the only place it can get unencrypted is in that cluster. And then the deploy story, being able to match the developer environment. Like I can actually now, if someone reports a bug in production and I can't reproduce it locally, I can just grab this exact same container that's running in production, pull it down to my local machine, and now I've got my developer tools and I can debug and triage that exact running code. There's no close enough. This is the same container that's running in production, now running here on my local machine. So how do we get to this GitOps nirvana? This starts with a tool like Argo CD, or there's also another one called Flux out there that's open source. There's tons of, I'm sure, commercial options. Argo seems to be the one we've landed on. I really like it. It's basically a very powerful wrapper around kubectl and Git with a nice UI and lots of pretty imagery that goes along with having the status and seeing all the containers and seeing all the action. Hopefully, if this thing goes as it should, we'll be able to see the kind of Christmas tree of stuff light up into that system as it handles and manages rolling out the deployments for me. And basically, it's Kubernetes native, so it runs inside the Kubernetes cluster or some Kubernetes cluster. It has whatever roles and rights are applied to it there. And then it watches those GitHub or Git repos, any Git repo, for changes. So it can sit and pull. It can also have webhooks, but we use just the standard look every so often, see if something's changed, see if a manifest has changed, see if a new release of the code or a new release of the container is out there. And if it is, go handle the kubectl applies to make this thing now live and do it very hands-off for us. So I mentioned that syncing automatically or on demand. You can also push a button and release an old version of a container out there if you wanted to. It has, again, I mentioned nice UI, and it supports other tooling too. So if you're using Helm, Customize, or just plain old YAML, it works alongside all those tools really beautifully. We actually have made opinions around all those things. So we use Helm, for example, to deploy Argo CD into our cluster. We use Customize to be able to manage the various environments. So I've got an environment set up for local, an environment set up for sandbox, an environment set up for the production and staging. But they have very minimal footprint when it comes to that's another objection I think folks have had for Kubernetes is going to be the amount of YAML you got to write. And I'm not a huge fan of writing YAML either. Luckily, tools like Customize help minimize that. And I feel like this is all enabled again by the SCAF tool. So the very first command I ran after creating the GitHub repository was a SCAF command. Was a SCAF command to basically build out this template onto our file system so we could start playing with it. I want to get to day 2 operation level at day 0. I want to be able to release right away and demo something. I want to have something live that I can have my stakeholders or business users go click on and try, and not have that be a 2-week-long process of how do I get this onto the cloud? You know, what technology stack are we going to use? Like, we've put together all of our years of experience in releasing battle-tested production code into this open source SCAF product out there. So if you just go to the 6feetup org on GitHub/SCAF, you can see that's the basis of the command line tool. It's got a couple different options for templates, so you can actually build your own templates for it and, you know, codifying your organization's opinions about how these things work. And under the covers, it's using other open source tooling like Copier, for example. For us, this is like cognitive load reduction. You want to focus on your app and not the infrastructure. Us as developers love building code. We don't love building YAML. We don't love deploying. We don't love shelling into a machine. We don't love reading logs. But these toolings, you know, wrap around all that and actually make it a little more of a joy, hopefully, to do all those things. And I mentioned before, we use Talos Linux typically for our production deployment because it gives us a very minimal, very secure, very immutable set of infrastructure so that we've just negated a whole level of security attacks. Like, the attackers are going for low-hanging fruit. I don't want our group or anybody we do work for to become that low-hanging fruit, so we just start off with a good stance. Again, day 0. What I love about SCAF, I remember, you know, I've been developing for a couple years, and I always would love watching the senior devs at their computers. It felt like they weaved magic on their laptops. They used all the cool tools and all the command line magic wizardry, and I wanted to do all of that. And so we took all that kind of magic and knowledge and kind of put it into a set of conventions so that every developer who works on a SCAF project now has access to Rough and Black and ISORT, has access into, you know, debugging tools and being able to run a debug instance so you can actually stop your IDE, you know, when running in a container inside of Kubernetes and have it all just work and have synchronized files seamlessly. So it's like all the cool tricks and, you know, tools and things that senior developers get to do, everyone gets to do now because you're using something like this tool. Okay, let's cross our fingers. Oh, no, shoot. Well, I have a backup plan. It's kind of like the baking show. We've just shoved that in the oven over there, and we're going to come over here and grab this one out over here. So fear not, we're not stuck. But I will go over that here in a second. We'll head back into the rest of the presentation, and I'll finish up with some of the demo. So just to kind of visualize this as part of the GitOps flow, you as a developer, really your main interactions with all this whole big piece of machinery is going to be the pull request. You make pull requests. As those pull requests get accepted, magic happens on the back end to make sure your code gets put into Sandbox or whatever environment where you're going to do all the testing. From there, that's where like the GitHub Actions handles that. Sends up the images into whatever container registry you want to, you know, of your choice. We just happen to be using Amazon. And then on the other side, the Argo CD controller in the bottom runs in your clusters, watches the GitHub, and when it sees those manifest changes, it knows there's a new image ready to go, and it deploys them across the various pods inside your node. It's really kind of beautiful, and it's easy, and as a developer, you should love it because you don't have to ever shell into a box again, hopefully. Because all the complexities of working with like getting the logs out of your Django instance are now, you know, make commands or kubectl commands to watch the logs, or use some GUI with your Kubernetes now, and there's some cool tools for being able to develop like that. This didn't come without a little bit of treachery. As the world has moved along and things have diverged from one another, you would think a tool like sed would be sed everywhere. But I'm here to tell you it's not. There are BSD versions of sed. So if you're running one of these fancy fruit devices, you're typically going to, out of the box, get this BSD sed version of it. But if you're running one of the more penguin-y-like devices, you're looking at a GNU version of sed. They're different. They say the same thing as a title, but they're different in the covers. And the same thing goes for a couple other tools. Like Base64 has different flags between BSD and GNU. TR has different flags again from these things. So we'd built a lot of infrastructure and a lot of scripting, and a lot of things had kind of gone into this, and then we realized not everything. We wanted to make this, again, as cross-platform as possible. A person working on a Windows environment, maybe with WSL, should have an equal opportunity as someone working on a Mac using the Apple Silicon, or the same person who wants to run a Linux desktop full-time. I've done the Linux journey, I've done the Mac journey, I've not done the Windows journey necessarily, but it should be possible for that to be done. And so we've settled on a tool called Nix, which also could be a whole nother talk of its own. But Nix actually encapsulates per project or per directory or per working area that you're working in, specific versions of specific tools. They're all pinned just like you pin your Django Python packages. Like, we want a specific version of sed in this project because maybe we're depending on some deprecated behavior, and maybe over in this project we can use the latest and greatest version of sed. It's a big, terrible example because sed doesn't move very fast, so I'm sure that hasn't happened. But I want to make sure that the binaries are compatible. I want to make sure I'm always using the GNU sed everywhere. I want to make sure I'm always using the GNU base64 everywhere, no matter whether I'm on a Mac or if I'm on Linux. And that's what this basically does. It installs all the common tools. It makes sure that every developer, if I walk up to another developer's environment in our company and I want to sit down and use their computer, I'm using the exact same version of those tools that are in my working directory for that project. I can move into another project and get different versions of those tools. Maybe you're always on the latest version of Rough, or maybe you're using isort in this one, not using Rough, and you're using Flake 8 over here. Those kinds of opinions can also be encoded so that they're reproducible, and that's what Nix does for us. It makes sure that those common tool versions match and that they're available to every developer who's on the project. And so when I say something to someone on the team, they aren't scratching their head and spinning their wheels trying to run some kind of product like that. So a couple things with SCAF recently. We've recently decoupled it from 1Password. We were using 1Password pretty heavily for all of our secrets management. We moved into just using the sealed secrets only and environment variables for passing things around. Again, making it more agnostic about maybe commercial options. I added in a dangerous mode. You don't want to do this. I don't think it's even documented, but for the purposes of this demo, I didn't want Terraform asking me all the time, do you want to do this? Yes. Do you want to do this? Yes. I didn't want, so I made a mode where it actually just says go for it, and it does. So that's got added. The sealed secrets are now automated. As you spin up your very first product and your very first project, and you type in that deploy sandbox, it's going to build the sealed secrets for whatever that target environment is. So when you go to do staging, it'll do the staging ones. It's all hands off and it just works. And it can grab those sealed secrets from various places or generate them too. Then we've got GitHub automations now. Prior, we were doing a little more ClickOps, going into the console and changing a few things around here and there and getting environment variables set up in the CI pipeline. That's all been automated with the GitHub command line tool. And we've also updated Argo CD to the latest version of it. So what does this give us? The kind of life before GitOps versus the after. No more are we like SSHing into servers. It's git push and we can deploy. No more are we doing a manual Docker Compose up, because that's another popular option. If you're using containers locally, you may be using Docker Compose. Well, Compose works maybe great on your laptop, but Compose isn't necessarily a great option for the production environment because you want to be able to release without shelling into a box or running some kind of set of automations there. So no manual Docker Compose up. We're fully automated and consistent. We really try and get away from the works on my machine, because I had a certain set of libraries at a certain set of versions at a certain set of binaries from certain vendors. Mine worked and yours didn't. How many people have had that magical combination that always works on your machine and no one else's? I've definitely had that. This works everywhere. Containers plus Nix plus all the other opinions that are kind of baked into this piece here, make sure this works everywhere. And now you know who deployed what where. There's no mystery, git pull and rebuild on a machine for a release. We now can actually follow the audit trail of what changes went into that container, who pushed that container, which keeps the person maybe signed off on as part of our workflow, and we have the ability to roll back. We can now roll back with a git revert or go into the GitOps tool and actually just push one button and get a previous version really, really quickly. So it gives us a little bit of breathing room to get our bug fixed and get the next version out quickly without having to stress about there being downtime or a pretty hellacious bug sitting out there in your production environment. So if you do want to get your GitOps journey started today, there is a one-line installer for SCAF. So if you just go to the 6up.org and hit the SCAF repo, there's a one-liner, click and paste. And then you just type SCAF my project, and it'll ask you some questions. First of them being, what kind of a project are you making? We've got 2 templates currently supported, one being the Django full stack app we just showed here, which I'll show you. And then like a serverless little dummy toy project to see how another template could be created. And then we get to deploy to AWS. We're using task files under the covers to automate running all the Terraform for you and targeting the various environments. Then now you can just edit YAML, change a file, and watch the magic all happen. What you don't need, and I want to also kind of emphasize this, I am not a Kubernetes expert by any stretch of the imagination. I know all the words I just said up here make me sound like I might be a Kubernetes expert. I am not. But I said at the very beginning of this, we're going to make this easy. And that's a word I try to typically avoid. I think all developers have fallen into the trap of calling something simple or something easy. I really wanted to make something that could go from complex to a sophisticated, fully deployed application very easily. And you don't need a huge team. I don't believe that Kubernetes and this kind of a style of working is relegated to only large enterprises with teams of 10 to 20 or more developers on staff. I feel that solo developers can benefit from this same level of consistency across all their applications. Because how often have you come back to an application 9 months, 18 months later, only to have bit rot and thing doesn't fire up again? And you're like, where did I leave off? This standardizes all those things across the board for you. So don't let that hold you back. In the presentation, there are links to the SCAF repos, some SCAF project info, the details about the SCAF full stack template. There is a Talk Python episode where I got on there and talked for like an hour and a half about SCAF. So if you want a detailed kind of a run through of it's a pretty big stack. Like, not only are we deploying Django, Postgres, Redis, Next.js front end, there's also Prometheus for observability, Grafana for reporting and alerting. There's a mail server built in there, like Mailhog for like local email development. So it's a whole stack of stuff that if you had to spend the time to figure out how to deploy each of these individual pieces onto your own machine, it would take a lot of time, and here you get it in just one step. Before we go, I do want to show you, that's sadness. I'm sorry about that. But we do have one up here running. Fear not. The 7th generation will save us. If I can, oh good, I'm still logged in. So this is what Argo looks like. It is nice. Again, that's kind of hard to just make a little bit bigger for everybody. You're going to see all the various applications that Argo is currently managing. And under the covers, it's managing itself. So you can see here's the Argo app that's been deployed into this cluster. We're using Cert Manager to handle all the SSL certificates for the applications themselves as well. You can see Cloud Native PG operators in here. That gives us the ability to do Postgres replication and backups and all the kinds of fancy stuff with Postgres. But here's the actual application we deployed, which is the DjangoCon 7 version of the app. Every piece in here, the Argo is monitoring the health and monitoring the Git repository and keeping all these things in sync and letting you know when things are getting a little out of whack. So if we saw a new release come in, this uses some WebSockets behind the covers, but it would actually show you like new stuff being deployed, old pods being spun down, new pods being spun up to basically handle that load in real time. But you can see here we've got a back-end pod, a front-end pod, and the Redis pod all running back here. In production, this may have n number of pods running your Django backend, so you can load balance across multiple nodes, for example. This is a single node Kubernetes cluster. That's one of the benefits and strengths of using the K3S open source Kubernetes package. I'm not running 3 servers to make this all happen, but I'm also probably not deploying this in a production environment. It wouldn't probably be ready to handle the load of a production environment, but it's great for sandbox and for testing and keeping the cloud costs down. And so you can see here when things are released, And then the app itself is going to be that's it right there. So that's the running. It's not super exciting, but it does have, this is what you get out of the box with SCAF. This is the Django powered backend from the Django templates itself. And then if you wanted to see, this should be the Next.js front end, also deployed. There we go. And so this is using GraphQL to talk to the backend Django containers that are also running inside this application. And if I were to make a change to the code base, I probably can, since this one, I do have this one saved. And I think I got a couple minutes left, so we can do just one little quick change. All right, why am I doing it in this? I should. There we go. This will be a little easier. Use PyCharm, because it's way easier for me to navigate and use on stage. 07, here we go. Open up this project. We'll go into the back end and we'll make a quick change to the template. Actually, if we look at the code on here, we'll try and we'll replace the word, SCAF powered. How about that? Okay, what am I doing wrong here? Oh, it's got the link around it. You're right. Good call. This should have my base template in here. Home extends base, of course. Okay. Okay, we'll save that. We will push that change up. Okay, now, here we go. See, there was the, oh, you're kidding me. It's because on the other side, so one thing you have to be aware of is that on the other side of what we're doing right now is that the GitOps is making changes and mutating your Git repository. So I need to make sure I pull the latest develop back down so that it can actually layer the changes back on top of it, and then we can push. Totally expected. Totally expected. All part of the demo, so I could explain that part to you. Okay. Now let's go back up here. We'll go to find the 07 repository, because we can kind of watch this happen in real time. It'll take a minute. Perfect. It'll take a minute to build over here, but over in GitHub Actions for this repository, you can see there's my change that triggered the CI pipeline to run, and it's going to run all the lint checks, whatever test suite you had running against it, and then eventually, as it gets to this update manifests, that's where the magic happens, and that's when our GitOps is going to notice a change over in the repository and make that happen. There we go. So it's going to build. The front end image takes a little longer to build. But it's going to keep them kind of linked together. It's like these two versions of the front end and the back end are tagged together. And you can see that if we go into this account. There's a Django 07 backend container repository and the front end container repository. So as it pushes new images up into that repository, it automatically handles tagging them with the hash of the commit that triggered it and in what environment it's currently in. So it'll move that develop tag to whatever is pointing to the container that's actually released on an environment. So it's kind of handy because now you can know exactly what's on prod, exactly what's on sandbox, and exactly what's, whatever maybe preview environment you've got going on too. Still building. Yeah, that's the only downside. I mean, we made a small change. It still does go through all the tests and all the machinery to build these containers. So it's important that this is a good reason why you want to make sure you focus on building slim containers, keeping them as small as possible because that'll speed this process up greatly. We've done a lot of work in here. There we go. Those are done. Update manifests, that is going. Now, if we go back over to the Argo CD for 07 and we refresh, we will see, yeah, these two are out of sync. So right now it's actually pushing the back end, going and grabbing that latest image that it detected and going to push out new back end pods. So you can see here's a split. These are the live ones, the one that's got the green heart on it right now. And this one is awaiting a health check to make sure it's good to go. So that's going to give us, again, our zero downtime delivery of the software. So it's obviously, it's not delivered yet because I don't have, if I refresh that page, I'm not seeing it yet. But then you also get, again, the whole audit log, when it got pushed, what changes are in it. Again, I know it's a lot of machinery, but I feel like it's worth this level of structure because most of the time you're not making a single line, single word change. But even if you were, you can now roll it out instantly with being able to go back into a different version of that container. What's also nice, you can see the logs. So you can actually see here this is the logs from the Django container itself. So you do get some visibility into the logs on production without having to give access to the Kubernetes configuration file. All right, we've got a backend that's up. There we go. We released some live code. So there we go. I'm excited that part worked. Luckily, planning worked out well for me on that one. Okay, and if folks want to talk to me about this, I will be at the 6 Feet Up booth out there. I love geeking out on this stuff. I get really passionate about good developer practices. I get really passionate about good DevOps practices. And this kind of brings both my worlds together. So I love talking about this. Happy to chat about it. You can find me in all these places. Come talk to me. I'm a very, very friendly human being, and I do love talking to people too. So again, thank you all for being at DjangoCon, and thanks for having me up here as well. And I think that's it. Thank you very much. Oh yeah, we got a question. I think we got a minute. Okay, hey, hit the question outside. Yeah, I think we're good to go. Thank you very much.